Hi, I'm Cliff Jacobs from the National Science Foundation. We're here at the second charrette, and I am with Regan Moore, and I want him to tell us a little bit about what he's been working on in his group. So tell us what your group is and what you've been working on.
I'm the leader of the Layered Architecture Group. This is a group that's exploring interoperability between community resources and collaboration environments. On this slide, we have an example of a standard analysis that a researcher might want to do. They want to be able to extract data from a community resource. They want to be able to modify that data and change it into the required format for their calculation to be done. So in this environment then, the goal is to automate all of the actions required for them to assemble the input files, generate the correct form, do the transformations. Typically for something like this, it's a very labor-intensive process. By automating the execution of those scripts, they can reduce it down to a very simple few-minute computer run. So this is one example where the goal is to do hydrology analyses in a watershed. You pick a stream gauge, it automatically generates the associated watershed, does the computations to do the transformation. If we go down to the next example, this is an example of integration with existing infrastructure. In this case, we're working with the cyber integrated workflow environment that's maintained by NCSA. They provide a web services interface. So from the collaboration environment, we can invoke their analysis. In this case, it's a rapid analysis of drought in Texas, monitor the execution of their code, and then when they're finished, automatically archive the data sets. So it's putting a scripting interface in front of an interactive environment that's currently in production and used to analyze river routing. In this final example, the goal is to be able to automate the association of input files and output files with the workflow. So in this case, we're registering a workflow into our collaboration environment along with normally the data. And what we do is we associate with that workflow a structured directory. So there's a tight link between this workflow and a directory that's established just for that workflow. If I put an input file, a parameter file, into this directory, the system automatically generates a run script. When I execute that run script by just getting it, it'll automatically generate a directory, store the output files associated with that input file, and now I have automated the links between the workflow, the input, and the output. If I put a new input file in here, the system automatically generates the new run file. If I execute it, it'll automatically generate the new output directory and store the output files. I can share the workflows, I can re-execute the workflows, I can modify the input, and I can do multiple versions of the output in this environment. So we could take one of the workflows that was being generated for either the drought analysis or the watershed analysis and now do reproducible science, be able to replay that workflow through the efforts of another researcher.
Thank you very much.